Hello, my name is Rob Reynolds. Welcome to Math 073. Today I'm going to be sharing with you how to simplify rational expressions, and we're going to be talking about section 5.4 from our textbook. I'm going to share with you two different methods how to simplify rational expressions, and rational expressions are no more than fractions. So the first 5 letters of the word rational is a ratio, and so these are complex because I'm going to have fractions in the numerator and even possibly fractions in the denominator. So we're going to try to simplify these fractions by two different methods. The first method is to find, by the way, I like this method the best. Method number 1, multiplying the numerator and the denominator by the common denominator, or the least common multiple. For example, the common denominator here, I call these baby denominators. So let me clarify here. This whole yellow is my denominator of this complex fraction, but in the baby denominators I can see I've got a 2, an x, and an x. And the common denominator for the baby denominators, if I just look at that, is 2x. So I'm going to multiply this complex fraction by 2x over 2x, which is really just by multiplying by 1. And I can multiply any fraction by 1 and still get an equivalent fraction, but you have to multiply this 2x to every term. So either I could draw these little arrows to signify that I'm multiplying by every term, or I would recommend that you write 2x on every term. So it'll look like this, times 2x times 2x. So I'm going to multiply, so I've distributed that to every term, and then a lot cancels here. So I'm left with x times x, which is x squared. These x's cancel. Minus 6 over, this is just 2x, and the x's cancels here, and I'll distribute the 2 for a 2x plus 2. So this comes down to x squared minus 6 over 4x plus 2. And I think that's the simplest way, using method 1, of solving this. Here's how the author chose to explain it. But again, the key is that they're multiplying everything through by 2x over 2x. You can pause the video and look at this if you'd like. So if we use method 1 again, my baby common denominator is choosing every factor. So I have to choose x, but choosing it the greatest number of times it appears. So x appears twice, and the y appears 3 times. So I'm going to have to multiply by x squared y cubed. But instead of multiplying it out here, again, I would think about multiplying this by every term. So I'm going to distribute that to every term. X squared y cubed. I'll write it over here, x squared. So you know that this is actually in the numerator, x squared y cubed, which is confusing to students because this, I call this the numerator, but it's the numerator of the denominator. So this yellow x squared y cubed is really divided by 1. So when I multiply this up, that's what I mean by the numerator. Those y cubes will cancel. So be careful how you write this. All right, so here 1x is going to cancel, 1y is going to cancel. So I still have an x and I still have a y squared. So if I multiply this together here in blue, I'll get 5x times x times y squared. Gets a little bit messy. 5x squared y squared. Here the y squareds will cancel, but it leaves me with 1y. So I have 2x squared y. Down below we already talked about the y cubes canceling, just giving me x squared. Minus 1y will cancel, leaving me with a y squared, so minus 5y squared. I guess before I say I'm done, I should probably look for a common factor, which we did in a previous video to see if at least I could cancel something, because the direction says simplify, and we don't want to leave 2 fourths. So I'm going to see if I can reduce, maybe pulling out an x squared y, which looks like a GCF. Down below, you could try to factor difference of 2 squares, but I don't think it does. But I would explore these things. In fact, maybe leaving things in factored form might be the recommended way to leave the final solution. So I'm convinced that we have the final solution. So remember, you cannot cancel part of a sum, so I can't cancel the x squared terms. But I'm going to leave it in factored form to be convinced. Let's see if the author agrees. Well, I think that's halfway through the problem. Yep. Good. The author chose to leave it in factored form too. Method 2 is, in my opinion, is a little bit more difficult. The suggestion is to add the numerator and then add the denominator, and then instead of dividing by a fraction, we can multiply by the reciprocal. So if you have 1/2 divided by 3/4, it's the same thing as 1/2 times 4/3, and then you just multiply straight across. I don't know if some of you may like this method better. I would prefer method number 1, but using method number 2 says just ignore this denominator for a moment and try to just add the numerator. And to do so, we need to multiply numerator and denominator by y. So we have common denominators of y's. Then, adding the numerator, I'll get 2y plus 1 over y. And instead of this division bar, I'm going to use a division sign and repeat the process for the denominator here. So again, I need to create a y for a common denominator, and it's divided by 3y minus 2 over y is the common denominator. But again, instead of dividing by a fraction, you can multiply by the reciprocal. The y's will cancel, leaving me with 2y plus 1 over 3y minus 2. The reason why I'm not a big fan of method number 2 is because it simply just seems like a little bit more writing. If I were to go back and rework this problem using method number 1, it would look like this. I would multiply every term by y, and I would be left with this guy, 2y plus 1 over this guy, 3y minus 2, and that just seemed a little bit faster because I kind of just wrote the solution. This seems like a little bit more work is involved with writing, but maybe it makes more sense. So again, here's how the author chose to work it using method 2. Again, I'm going to use method 2 here. I think I'll work this problem out both ways. I'll use method 2 and method, but let's use method 2 by just finding a common denominator. So up top, the common denominator is AB. So I'd have to multiply the numerator by B, and 1 times B is B. I'd have to multiply this guy by A, so plus A. And I think the key here is to hit divide by and repeat the process for the denominator, which I think the common denominator for the denominator is A cubed, B cubed. So I have to multiply the first one by B cubed. B cubed times 1 is B cubed. And this guy is going to be multiplied by A cubed. So I get a plus this guy, A cubed. And then I have to rewrite this. B plus A, which is the same thing as A plus B, times, I wonder if I could factor this, because it looks like cubes. So I'm going to write down the bases of what's being cubed. I'm going to square the first, take the product, square the last, First you keep the sign, then you change it. Last one's always plus. That's a previous video if you don't remember how to factor cubes. Oh, I forgot to hit, I'll rewrite it because I should have written that in the denominator, but I'll rewrite it so you can see. Instead of dividing by a fraction, you multiply by the reciprocal. I could have probably saved a step. Now it looks like some things cancel. This b plus a cancels with this b plus a, which is nice. And one of these ab's cancels with one of those ab's, so I'm left with a squared b squared over b squared minus ba, which is the same thing as ab, plus a squared. And it looks like the author has the same solution. So I'm going to go back to method number 1 because I like it a little bit better. If we multiply by the baby common denominator, this time it's going to be 15. I think I can just write my final solution. So 15x plus, this is a 3, divided by 15x minus 5. Final solution. I think the author chose method number 2, but again, method number 1 works really slick. Here's that same problem that I worked before, but I'm going to use method number 1 this time. And it says look at all of the denominators and choose the common baby denominator. So I have to choose a cubed, b cubed on every term. And let's start canceling. A cubed divided by a is a squared b cubed plus a cubed b squared over b cubed plus a cubed. Well, just like before, we could factor this denominator. So this is going to be a b plus a. Again, the rule says write down the bases, which are what's being cubed. That's b and a. You square the first, take the product, square the last. First you keep that sign, which we already did. Change it. Last one's always plus. Up top, I think I could factor. Let's factor out an a squared and a b squared, leaving you with, if I divide this by a squared b squared, I'm left with a b term, plus if I divide this by a squared b squared, I'm left with just a. That will cancel, and again I'm left with the same solution I had before. So two different methods. I actually prefer this method, but if the other method made more sense to you, you're welcome to look at that same solution. If you see something complicated like this, I would definitely use method number 2. I would factor this thing. So factoring the numerator here, factors of 6 that differ by 1 are 2 and 3. Signs are going to be different. The larger term is negative, y plus y minus, divided by factors of 14 that differ by 5 are 7 and 2. Signs are going to be different. The larger term is negative. I'm going to hit divided by factors of 5. Well, can I save a step? Let's hit times, and then we're going to put this denominator in the numerator, so I don't have to rewrite it. So factors of 7 that differ by 6 are 7 and 1. Signs are different. The larger term is negative, y minus, y plus. And then that's going to place the numerator in the denominator, because remember, instead of dividing by a fraction, we can multiply by the reciprocal. So factors of 5 that add up to 6 are 5 and 1. Signs are alike. They're both positive, y plus, y plus. So again, method 2 serves a little bit better here. Any numerator with any denominator can cancel. So I think these y plus 1s can go. This y minus 7 cancels with y minus 7. The y plus 2s cancel. Anything in the numerator can cancel with anything in the denominator. And I think that leaves me with this y minus 3 over y plus 5 for final solution. And here's how the author chose to write. Oh, they did the same thing. Instead of dividing, see this is division bar, instead of dividing by that fraction, they multiplied by the reciprocal. They just rewrote it from the beginning. I hope you found this video helpful. Email me with your questions. Thanks.